All right. Together with Armin, we are going to double-click on some of the things that we saw in our keynote. How we're going to be using artificial intelligence behind GeneXus to develop software, but also we're going to go a little bit deeper into the features that a business app requires at present to make a modern app. Not only the question of AI is important, but many other things are important as well. So I'm going to start with how we think software is going to be developed. And when we did some research with some people some experts who think or predict how software is going to be developed, one of the article, Victor and Timothy, one of the articles is an article, it's not even any research work. It says, why is it that Johnny can't hate or can't program? And from there you have a full tree coming out of many people talking about that article, where basically the question about programming, what programming is, that is to give instructions one by one to a computer, to some software, or through some software, so that it reaches a goal, it achieves something. And the fact is that apart from the fact that we must all learn how to program, well, the truth is that Johnny is perhaps an expert in an area that is also complex and has no time and no idea and no wish to start programming, but he wants to solve things with software. Johnny may be a financial specialist, or he may be in the retail industry or in other areas of entertainment, and Johnny is never going to migrate, changing codes, instruction by instruction to computers through something that we engineers invented as to how to do things. That's not going to happen. Not everyone wants to code. And so this takes us to the thought that we want to share with you. We were talking about the software paradox. Many companies have software, and from the time we think or we say what we want and the time we code, a long time elapses. And so right now we're not alone, we're not on our own, reduced group of those who think, as Nicola said in his keynote, that I'm going to be able to build code, giving out the goals and certain rules and constraints of what I would like to do. And the Copilot site mentioned that. What we are looking for is to move from the goals to the results, skipping many steps that we take for granted or something normal. And so, as I said earlier, we started with Johnny, and Johnny is someone, imagine that this was artificial intelligence working in the 90s. He said he wanted a video club, he has customers, and so on. You can go on talking, chatting. You can make some manual edition of some things, and you can say, well, improve this. Jose Lamas is going to be going deeper into these chats, but our dialogue with AI are not only a request and to obtain a result, but it's a request to obtain a result, and then I can put it in a loop and then get something that is quite entertaining of what I can get. So I can say, all right, improve this or improve that. And now we're going to see why we made this video club, which we're not going to do now, of course. But basically, what's happening is that as from natural language, we're not generating codes. What we want is that on the basis of natural language, have a system, a full system, with different functionalities that is posted, that can be, that has a nice coverage, that is functional, that is secure, with different suppliers or providers. And those are the first steps. Now, as I said earlier, we fell short, and it would be quite optimistic to think that a system with the complexities we are facing right now, you can build it straight away from those chats or conversations. It would be quite uncomfortable in some cases. And so the important thing there is that we went from GeneXus to a development, web development environment for Mac, for Linux. And in fact, it's not just what we had been working on in GeneXus M when you have an IDE connecting with a server, which had to be Windows, because we are also sharing all our platform, .NET 8, and that platform runs on all possible operating systems. But we went even further. Our generators, our specifiers, we could go through many barriers. And we are thinking that in this environment, natural language has to continue being a tool to improve each one of the objects that we can improve. How to edit the rules. For instance, we're going to have the transaction structures. We have text and structure and also natural language to be able to build them. I'll be able to create not only transactions, but also different types of queries, different types of processes, and so on and so forth. Jose will go into this deeply. And there are going to be some talks about, well, I don't want to stay there, but just think that systems are only built by engineers. That's an illusion. A large part of the work is done by pro designers. They manage the flows, the interactions, the information architecture. And most certainly that human-computer interaction, such as psychologists and sociologists, they all have to work together to give a certain tone to the conversations, things that were basically written on in books, but when you were doing these systems, you weren't applying them. Now we are applying lots of these things, and on the basis of natural language, you're going to see that there are many talks to build wireframes, Sigma, and the positioning of the information structure, and then move on to the design system, fonts, colors, spacing, all that kind of thing that will truly be another fidelity in terms of design, and we're going to export it and move it forward. So the how, what we are doing is using natural language plus GeneXus assisted by AI to get to the enterprise system. And I'm going to double click on what we did behind all that and what's behind. And what we have behind, and I'm going to be giving a talk in particular this afternoon about the challenges that you have when you start interacting with the foundation models. And these are models, and I'm not going to go into details, but these are deep learning models. And on top of that, these are models that predict the next word. And given a text, it predicts tokens or words that can follow. And there, the challenges lie behind. I mean, all this talk that I showed you in GeneXus, well, I'm having a dialogue with different models. Some are AI models, others are anthropic. Depending on the task, there are some models working in some way or the other. This is an image generated by DALL-E of a generalist model that knows everything. But these models involve some important challenges. Industry is working very strongly on each one of them, and that is when I talk about something very technical and basic is how can I align that the output of that conversation is something that I can take up and process. For instance, give me the way out in XML or JSON, for instance. And doesn't seem to create any problems. I should be able to do it. There has been some progress this year so far in that area. It's not a minor issue. That is, how can we align things for things to work out every single time, not sometimes. Now, the other important thing is that these models were trained with lots of data. They are open models. And many of them had open data sets, others we don't know. And when I start having a talk with us about something, what Nicolas said today is that they hallucinate. That is, basically, is to write something that is all right, but it's a mistake. For us programmers, it's a mistake. If I said create a JSON and it doesn't, now at some point in time, someone will have to put in that exception. And so when we start talking about certain things, for instance, talking about knowledge base, what the knowledge base includes is your own property. And then I have to talk about that, not about what the model knows. That has all the data. And to make that link is a challenge. And many models have certain restraints because to explain to the model what I know about my business, I have a window of memory to put in the LLM to the model, which is small and limited, and so I have to think about what information to put in. I have to make select. I have to go several data, put in some filters and ranking, and then put all that, summarize it, and try and occupy as little space as possible. And you're going to listen probably to. Well, we started with 2K or 4K model, and we celebrated because now we have 16K or 32K. And we want to get to gigas, but the latest AI models are 132 Ks and so on. It doesn't mean that it always understands things right. And the other thing that isn't minor is security. Therefore, when Johnny is talking, we also have the challenge of experience. And so what we did with GeneXus was to try and what Johnny says, we have to put it as goals and constraints where we try to encapsulate this little monster lying behind and to keep it in place and to be sure that what I'm showing, Johnny, as Federico Domiano was showing earlier, isn't an hallucination. In some places, for instance, we have much more tolerance. For instance, in image generation, we have more tolerance. Between something that's perfect and something that is so-so, people don't realize that, except image expert. But when you see a text that is badly written or when something fails in programming, you realize that immediately. So from the experience standpoint, we have to make experiences for Johnny that are visible. Johnny must understand why these things happen. And so we start having a dialogue with these AI models where we say, well, tell me this, but also explain to me why. And it's very funny, and I'm going to say this about, I'm going to discuss this in my talk, but anyway, what we try to do is to play with certain certainties in a probabilistic world. We are in a probabilistic world, having a dialogue with the stochastic processes, and they are not giving us any certainty that things are the way we think they are, and so users must be shown what's happening. And then the other thing I mentioned earlier, we aren't going to replace everything by a chat. I was in San Francisco a couple of weeks ago and looking into a group of experiences that are new and where chat is important, language is important, but we also have to agree on the fact that we understand what's the spatial, what's face, what we can look at faces, and we know how to manipulate, to move one thing to the other thing is much easier than to give the instructions and explain how to move it. And then the question of explainability. Now, how are we doing this? Well, we dialogue with this little monster behind all this, trying to do the correct rounding and so on in multiple models, not just with one. And then let me explain why we have multiple models. Because there's a question of costs, latency, where it's posted, where data travels from.
The goals, what we do is the following. We generate a knowledge base, and then we build what we call the systems using well-known generators. Armin will talk about that, and I will add more details. But in the knowledge base now, we will start having not just, if you remember, Johnny was a video club. Imagine that this was in the 90s, and Johnny probably told it, I want to know about the classification of films, because Johnny wanted to organize user groups to exchange experiences relative to the different films, or to have a classification, to connect with friends, who knows. All those things, that information which was not structured, used to get lost. If I tell AI today, someone organized a video club in the 90s, what would the equivalent be today? Well, maybe they mention streaming, and entities should use certain things, and the conversations to classify films in a form now would be on the web. You do the classification as you watch the film. Maybe Johnny wanted to know what the users preferred so that he would bring those films to the shop so as not to lose money. So all that information that was not structured will stay in the knowledge base, and that information can be used. What is interesting is that we today can synthesize knowledge that will persist, and we will retain the meta information. So with that information, I somehow can ensure a future proof. In 10 years' time, if I try to analyze this, I will be able to use that information. So I would say that as important as building is the role of keeping, storing that knowledge. So how to do that? Many people today are programming with comments that get lost. And they are happy because they think they have kept the code, but they don't have the why things happen. So we will retain knowledge, and that will allow us to edit with GeneXus. And that GeneXus is going to be freeing us from many barriers. It's the hardest engineering piece we ever created. And for the first time, we have been working with people that do the proof design, and they do the interfaces, and with the software engineers do the hardest part of connections. And from that knowledge base, we will generate code. And that code, maybe I could tell you what we're doing in terms of code generation during the breaks. We are creating automatic generators for generators. So in general, our approach has always been generalizing generators from end to end. But if I know what Johnny wants, maybe I need to generate a generator for the platform Johnny wants to use. And I could replicate the same diagram using code generation. I hope this is clear, and maybe next year we have something else more specific to share. I will now close and give the floor to Armin. But before I leave, I am convinced, and I saw it over the year, many of the things that we had to do disappeared. We won't have to do them again. We have fallen in love with solving problems and creating better software. So many parts of GeneXus may disappear as such. We are not going to hang on to techniques that do not contribute to a solution. I'm convinced that all the flows in all areas, at least in software development, will change. Requirement analysis, construction, testing, quality assurance, security, all the flows are changing. I don't want to alarm you, but let us do this happily. Now I'll give the floor to Armin.
Gracias, Gastón.
Thank you, Gastón. Thank you all, and welcome. I will continue this conversation that Gastón started. But let us now think about what software we want to build. In this community, what we create are solutions. Modern enterprise solutions. They become modern from the very moment they are built. They stay modern. They are critical emission solutions. These are solutions that if the business stops, the solution stops. We are good at doing this in this community. So the new challenge is that those modern enterprise solutions will be leveraged by AI. We want to really tap on the technology to provide new experiences and simplify them. So this is what we shall build. And that is not a solution. We need a lot of work to do yet. We have many challenges facing us to create that type of solutions. What and how are the challenges? So let us walk together to look at the creation of systems and see where we need to be more careful. From the very beginning, we asked Johnny, where would you like to install your solution? He won't be able to answer. Johnny probably wants us to have the solution in all the channels we have here. Why? Because sometimes we know the technical details, and we know that it is not the same to do something for an Apple Watch or for a browser, which is a different technology. So we ask him, are you sure you want that? And why not, he will tell us. So we have to build today. We have to build multiple experiences, and that does not change. But what changes now is that we have more experience to build on. We now have the super apps. That's a new channel. My app can be a mini app. We have the private chat environments. Echevarriaga talked about this in Globant. If I'm a Glober and I want to have a new solution for Globant, I can have another channel in private chat. And this is going to happen in your own companies. Or if it's public, maybe I want to include it in Chat GPT. So just with one natural language interface, I can have this solution. So multi-experience is not over. What we have now is a set of new channels to deploy and new knowledge to deploy. The natural language is clear that it plays a major role in our solutions. And people will interact through text, voice, image, and video, multimedia, gestures. These are new interaction modalities, and we need to be ready for that. And these new interaction modalities will create new interfaces and interactions in our applications, like chat. Chat becomes predominant. And the search, we have the search since Google added a box for search. We do the same in our applications, but then it will change the nature of the search, which is going to be more semantic. I'm not writing 3 keywords to look for something. I'm writing a complete sentence. I'm providing context, and the search is much more intelligent. It's semantic, a semantic search. It has a different nature, a different technology that leads to the same objective. We have intent-based interfaces, or if we use the autocomplete trend, this is also very easy. So here we have new experiences for the user. And if we continue along those lines, I will really make Johnny a little bored. And when I start explaining the non-functionals in critical emissions, here we have many things we want to respond to, how to build those solutions. We know that what I build today will not stay isolated and needs to be connected to other solutions. Maybe I can sell them as a module or as a composite. Maybe the same solution has subsystems. Each of the subsystems will be maintained so that my solution is always modern. I will like it to evolve or maybe make it portable to new technologies. I can go from one cloud to another. I don't want to be tied to one supplier. So these are all characteristics that our solutions must incorporate, apart from others which are performant, scalable at certain periods during the year, that responds to the user's needs, that is safe, that is observable. If I have so many components, I have entry portals. So security is important at all levels, and we need to observe when a flow crosses all these components and all parts of a solution. I may wish to know where will the flow break apart. These are things that we engineers know, and we have to bear them in mind when we develop solutions. If we use a traditional manner, maybe we may have expert teams in each field so as to prepare a really good business application. Let us look at another architecture. We have users interface, we have all the safe layers. No, nothing new under the sun in this AI era. What is new is the LLMs. So what do we have here? Can I connect my solution to some of them directly? Yes, the APIs are well defined. I can do it. But do I want to do it? Do I want to go to one in particular and tie myself to that? Or do I want to have something in between? We believe that we need to have something in between. When we created GeneXus Next, in fact, we thought we needed something in between, because we were creating new assistants, new versions of assistants, and we would break something of the previous one, and we had to create something in the middle.
Language.
Something that we were calling LLM for questions that were being repeated. And when we cached it, we said, why not? And so we said, how can we analyze these costs? And so in that middle engine, we said, why don't we add observability so that we can know what the calls are to those LLMs, and we can estimate costs. We can know the real costs that we are having and estimate them for the future. And why is it that if we have those intermediate requirements, why can't we learn from them and keep them and learn from them in the future and build better models? Therefore, we could see that that intermediate layer is essential. And that's why the product that Nicolas released earlier this morning, and we're going to give you more details. But there are many challenges involved, and that's what I wanted to focus on. And that's why this layer is super useful for this new era. And so, what about GeneXus? What does GeneXus offer for all this? What I'm showing you now is a diagram, the basic GeneXus diagram that we showed you here 30 years ago. On the basis of a business reality, we describe that and rewrite that on a KB, and on that basis, we generate all programs and database. Gastón explained the question of AI earlier, how generative AI will help us to describe in a better and faster way all those requirements about our systems, right? But we've been using AI for 30 years. We are using symbolic AI to generate those programs and those database. And why is it that it's fundamental? You may recall what Nicolas said. In this new era, we are going to have two scarce resources. One was trust. And we know that generative AI sometimes has hallucinations. No, it's not. It hasn't got illusions. It has hallucinations. Now, these code generators use symbolic AI, as Nicolas said, and it's always generating the same output from the same input, and then we can trust. It's a scarce resource, but we have available in this new era. The other scarce resource is Dominion experts that will require to do all those things that are so complex. I mentioned 15 or 20 complexities and challenges that we have to build modern applications leveraged by AI. We need Dominion experts, but we do have Dominion experts here, and these are our code generators. They are experts in each one of the areas, in each one of the parts of our solution. And so we are going to see now what GeneXus and its generators use for each one of these layers that we have to create. At user interface level, the generators that we have are generators for the entire web experience and for the native mobile experience. These generators, specifically native mobiles, are useful to make the super apps and mini apps. Now, these generators may help us cover all the spectrum of user interfaces that we require. Now, these generators are updated, and we keep them updated to the latest technologies. We do the entire research and development so that we're always generating for the latest version. In December, we're going to release upgrade 7 for GeneXus 18, and it's going to be working for Angular 17 and the latest versions of Android and iOS. Angular generator, well, we started developing for Angular 8. Now, the same code of the KB is no longer generated for Angular 8, but in the meantime, it muted it, and it's moving to Angular 17, and it's wonderful because otherwise you would have to do it by hand. We're going to go deeper into this during this event regarding event design issues and specific issues in each one of the platforms. If we go on now, thinking about the business logic, there are generators, backend generators are Java and .NET. Both evolved strongly this year for this new era. Java generator generates for a new framework called Spring. Now, this framework is the one used the most in the Java community. In fact, in any company where GeneXus isn't used, that framework is being used, and we expect that Java applications using that framework, that will be part of the clauses or the policies of the company to use the same one. And now GeneXus is also generating for that framework so that we can have less friction whenever companies want to use GeneXus. And also for GeneXus users, there's an advantage. Prototyping and installation is more agile if we use Spring. Java generator is updated to the latest versions, and we also look into how to generate by hand. We always deliver the generated code, and that generated code forms part of an entire process of production, and that code is ready to integrate any process and any production process for solutions. And the same thing happens with .NET generator. We've got it in 2001. We released it together with Microsoft when Microsoft related .NET framework, and so that evolved, and .NET 8 was released 2 weeks ago, and it's going to be ready for the next .NET 8. We had something like 3 or 4 months moving from .NET 7 and 8, and we took up all that work in our R&D area, and the generator is now ready. So those are the 2 generators we've got now, and we can do and keep entrepreneurial solutions updated and leveraged by AI. For our future, we are thinking about a new generator. We've been working on the new generator already. It's a generator that's very much used at international level. It's a generator that will allow you not only to compile an application, so we'll be able to prototype in a more agile manner. And the execution time is also running in a light environment. And I'm saying it because that's the way they describe themselves. In OGS, they describe themselves as running in a light environment. But Ignacio Roqueta, who is the owner of Java, is quarreling about who is the lightest one. And so Ignacio will follow up this discussion in his chat. Anyway, we want to have this generator ready next year, and we're working on it. At data level, there are also changes. There are new challenges, new DMS. With GeneXus, we connect with all relational data, with document data, and so on. Those are tools that we use in our generators, but all the semantic search that I mentioned earlier, vectors, graphs, new database vectors that will help us in these solutions, which are being leveraged by AI now. During all this event, you're going to be, you will have talks. I've already told you about Ignacio's, and also Claudia that will be talking about .NET 8, APIs, The importance of APIs in this era is particularly important. Together with Aniel Monza and GeneXus team, we created a GPT about 2 weeks ago, and we only had to describe the API, and we did the same for GPT for G30. So we created a new interface, a new input channel, and the only thing we had to do from our side was to generate an API and its description, and that's done by GeneXus, and it's done very well. So in this era, to have APIs is also very good. We're now going to move to the last layer, and that's what we call the large language models. As I said, what we are offering right now is GeneXus Enterprise AI, and that product is the result of our own internal needs to build the new edition, GeneXus edition. We've made our first learning. That's where the idea was born. And then when we started thinking about how is it that users will use apps in the future and all the AI needs that gives out in the apps, well, this exactly that what we're using for building is going to be used for apps, and it was madness. Eugenio Garcia was making demos every single day because it's providing high value, and we think it's very useful. It's going to be very useful for all of you. In the afternoon, Gastón will tell you more about this problem. Eugenio will present the solution. We're also going to have demos in the event so that you can see them. And the last point, one further point, has to do with security. Security at all ends. Martin said it earlier. He said, GeneXus is a tool that facilitates or takes away any fear of adopting AI, thanks to the fact that it simplifies security. Well, I haven't said it exactly in the same way he said it, but that's what I recall. The point is that people sometimes are afraid of adopting AI because of security reasons, and GeneXus is really simplifying everything. It places security at all ends and simplifies the work, both for developers, engineers, and those putting things in production, because of all the things that are done automatically. So again, we follow rules of WASP automatically for native mobile, and that international organization that looks into what the maximum vulnerabilities are in each one of the solutions has also detected possible vulnerabilities in LLMs. And it gives guidelines as to how to solve them. Well, GeneXus Enterprise AI has already taken into account some of those guidelines, and there the question is simplified. All right, all this is not only a generated code, but it comes with a module called GeneXus Access Management, GAM, and it follows strictly all protocols required to make modern entrepreneurial apps, and it has all the engines for all suppliers in the world. So about security, there is also going to be a talk. So far, that's all the challenges and solutions that we've got in GeneXus in order to simplify that development of modern solutions, and that you can keep them up from now onwards. So before making a final remark with Gastón, I would like to share with you some cases that we've seen along the years. The first success stories are ours. We are using everything that we develop in order to develop our products. GeneXus Next is developed with GeneXus. GeneXus Enterprise AI is done with GeneXus. GX Flow, the inbox, the engine of workflow, is one of the most powerful in the world, is done with GeneXus. The security model is done with the GeneXus Wiki, documentation system. The app that you're using right now is done with GeneXus, the identity provider, and all the developer systems. These are modern solutions. We ourselves can see them and build them, and we go all along the process, and we rule the life cycle of solutions, learning from ourselves, not only from you, in order to build and improve each day. But in this event, and this is far more important, in this GX30, we're going to have over 30 success stories in the talks that you're going to be able to attend in these 3 days. You're going to see the main players, the community, telling everyone how you're doing in adopting GeneXus. It could be food, could be internally, software factory in Globant, how processes are being optimized in one of the main banks in Japan. We have a delegation of over 20 people from Japan. We are extremely thankful because of the long trip they took to come down here. We have an enormous responsibility to respond to all that. So thank you very much. Thank you all the delegation of Japan for attending.
Y siguiendo con esos casos, también
Also the startups, the software houses creating their own products in the field of insurance, building modular solutions, RPs to distribute. So we'll have examples from different fields for you to see, for you to learn how to make modern solutions leveraged by AI. I will now invite Gastón for a final idea or thought. Stay with me. We are closing the morning session. It's been a year, as Armin said, where we've been working very enthusiastically. It was a roller coaster. We were doing one thing, and then we had OpenAI, or then Microsoft or Google contributed something. The whole community of open source, Meta was also contributing with models. So this vision found us as we were building. That is good. Because what we did with GeneXus Enterprise AI was very good. And things we used were things that could serve us and could serve others. And we also worked on more specific issues. But let me go back to this conversation that we started with Johnny's Enterprise. The story was written by Gabriel Simonet. We have our conversations with different teams, especially the design teams, experience teams, and we have good results. When we were reflecting what's next in the development of software, I think it was the CEO of Mastodon who has a Twitter blog. From the moment, he said, somebody tells us about a system they want to develop, maybe in half an hour it's ready, or even less. When we turn around, we talk about it, it's very easy, but then it takes time to produce a system. From the beginning of history, Nicolas and Brogan said, well, ideas are here. How long will it take us to build on those ideas? Some people have lots of ideas. They don't want to code. And that was the first thing we observed. So there were different tools that could be used. Today we call it low code, but we need to write less code so we get closer to using the software, because Johnny wants to use the software. Otherwise, we waste a lot of time. So GeneXus and our tools have been a step in that direction to really reduce the coding time. Some people have to do the hard part for the connection, but then in recent years, We wanted anybody to produce software, but for that we still need developers. Somehow we still need developers to do code. Then, in recent years, we had the no-code development, where each person could invent a way to use the software as soon as possible. You invent a sort of language with a mental model to attract more users. And there are very extraordinary tools that only address one part of the enterprise system. But in large companies, you cannot use all these different tools because you start disaggregating. There is nothing that unites them. So I think that our next step is not a matter of inventing a tool, because we all know how to use natural language. It says here, everybody creating software. So everybody means whoever knows what they want to do, whoever is reasonable in terms of computing, they will be able to create software, because we are having conversations with someone. This is something serious. If Johnny knows what he's talking about, he will be able to create software. That is why it is so important to have critical thought. That will not be replaced easily. So through natural language conversations, we get to a safer runtime. But maybe we could go a step forward. One thing we have detected is that with the natural language, we separate development time and runtime. Because what happens is that if I am conversing and I am manipulating at the same time, we need to separate this into two different phases. Because in the software I'm creating, I also need to create something. For example, I have to create a new query or a new process that wants to be connected to runtime data. But what we see today, and that is why we have included generators that will allow us to get to the point where runtime will allow us to talk in a more natural way. If you use ChatGPT, it generates Python code and executes Python code. So what does this person want? Is it a drawing which is not in the Excel templates? It's not a chart, it's not a pie chart, it's not a bar graph, it's something else. It's human imagination, which is much broader. So it can even create a program that shows that visualization in runtime. There are no constraints. So this is what we want to do with GeneXus. We will connect all the stages, the design time and the runtime, and that's why we created GeneXus Enterprise AI. And now you will close. Armin. Yes, I will close with this reflection that Gastón expressed. What we really experienced in the last few months and weeks is that sometimes we do not know whether we are using or creating. When technology is so advanced that we cannot differentiate, it's because we are getting closer to magic.